Good evening.
Thank you for all coming along. It's good to see a big turnout. Quick intro, my name is Richard Brown. I'm the specification manager for Ideal Commercial. I normally control the streets of London with Ideal Commercial.
Someone's got to make a living somewhere.
I know, but I think I'm doing a UK tour, doing the CPD, so, so this is the Birmingham one. No, so yeah, so concluding the name specifications. So I generally look after anyone who specifies a boiler basically, which is predominantly consulting engineers, and as I said, predominantly in central London. Peter Breeze, who is our local contact, or will be your local contact for this area, for Ideal Commercial, has joined me this evening. So he'd be sort of your day-to-day contact. But hopefully all of you have heard of Ideal Commercial, you're familiar with Ideal. I mean, those of you that aren't, a quick intro. We are a UK-based manufacturer of commercial boilers. We manufacture up in Hull, up in Yorkshire, and have done for about 108 years this year. So, got quite a lot of experience in that. On the commercial side, we manufacture everything from 30 kilowatts to 150 kilowatts on the wall, and then 80 kilowatts up to nearly 1.5 megawatts on the floor. So we've got something there to meet most requirements. But really, what the CPD is about this evening, plant room surveys, and we're calling it an introduction to plant room surveys. But it's not just an intro; it can be a refresher as well to some points that us as a boiler manufacturer think that you need to be looking at maybe when you're doing a plant room survey. But it's really geared up around retrofit surveys. So not new build or anything. We're looking at existing buildings such as this, and we need to change the plant in that building. So what we're going to go through, I suppose, three main points: the initial assessment, so assessing the plant room, what do we need to look at replacing, the actual replacement itself, and then going all the way through to the final part, which will be the commissioning. What we hope you're going to gain from this is obviously the what you need to assess when you're looking at the replacement heat source, looking at the potential risks as well, because there's going to be risks involved because we're looking at an existing building. So it's not like we're looking at a new build that's not even out the grounds yet. We're in a nice clean environment, just looking at drawings. We're actually, we're looking at an existing building, so we've got to get down and dirty actually in that building. There's a few points there, the importance of pre-survey checks. There's a few points there. We'll go into a bit more detail in those within the presentation. And then finally, the commission. But when we look at the applications for the retrofit, obviously there's a number of factors we need to consider. We say that a plant room survey can help avoid such issues as plant oversight. And what we mean by that is it was probably common practice, I suppose, maybe 10 years ago, 15, 25 years ago, to almost sort of oversized plant. You'd do 100% run and standby. So see, now we do things slightly differently. So potentially we could look at actually reducing the size of the boilers that we're putting back in. Other things as well, obvious things like efficiency savings. If you think modern boilers are now far more efficient than older boilers, so we can look at saving the client money. And other things as well, like NOx emissions as well. New boilers are far less harmful on the environment as the older boilers. So there's a few little factors there that are actually attractive to the client. But we can also look at space saving as well, because again, you think boilers years ago, if you were looking at 200-300 kilowatt boilers, you barely fit them in a corner over there. But now we can get 300 kilowatts on the wall, so we can actually look at creating space in the plant room. And by doing that, the client, the end user, the building operative can actually look at possibly creating maybe another room or whatever within inside that building. They'll love that because then they can actually make some money from that. So, but initially, you guys, you're the ones that have to go and do the survey, and that's really what we're going to go through over this session. What we'd always say, first point of call will be a risk assessment. Is that something that you'd normally do as a matter of course? I always ask that question because quite often I get a few sort of nods, a few grins and whatever, and A lot of people say to me, well, yeah, we know we should do them, but we tend to oversee it. But I think it's important to do that because you can pass that risk assessment all the way down the line, all the way down to the guy who's got commission at the end. So if there is anything important they need to be aware of, they can be highlighted. But really a few pointers that we think you should be looking at on accessibility for the boilers themselves, pretty obvious I suppose, getting them into the plant room, also getting them out of the plant room as well. You know, you think, going back a few years ago, it was quite common practice to almost build a plant room around the boilers with no consideration to plant room replacement strategies. Because you know now we have to go through that whole plant room replacement strategy process. Years ago that wasn't done. But by doing that, measuring the things like doorways, plinths, etc., looking at the lighting, so lighting within the plant room, lighting along the way, do we need to address that? Noise levels as well, I mean not just noise levels that within inside the building, but things that we're going to be creating when we're doing that replacement. So we might need to look at things like out of hours working, if it's particularly sensitive to that. The environmental conditions along the way, I mean the floor conditions as well. I think we're looking at an existing building, so there could be trip hazards, for example. I mean, is a site induction required? Probably 9 times out of 10 we have to do a site induction on most sites. Last point on that side there, the asbestos register. Again, probably the most important thing you want to be looking at. Older buildings riddled with asbestos, and the last thing you want is to forget to look at that, and then you get your contractor going to site, start ripping the ceilings down and old flues out, and all of a sudden you've got asbestos dust everywhere. And that can, I mean, I speak from experience recently. There's a project which I'm involved in down in London where I got told the other week that the project had been put back 2 weeks because they found asbestos on the site. Really, that should have been picked up on the initial survey. Would PPE be required? I mean, you'd cover that under the site induction. Would road closures be required? I mean, if you think if you're delivering large items of plant, the last thing you want to do is to get your large lorry come down the road and start blocking roads, and then you've got issues there. So if we need to look at road closures, again, things like that can really take time to organise. Crane lifting, obviously lifting equipment, lifting up onto maybe a rooftop plant room, but also lifting down as well into a basement, things look at high ups. And then loading restrictions as well, with floors and lifts, that kind of thing. It could be that we've got a nice goods lift, but maybe the goods lift isn't man enough to take the boilers that we're proposing to put in. But also, the floors along the way, they're mezzanine floors that maybe we need to be aware of that maybe have got loading restrictions on them. And look at the checks themselves. I mean, first up, categorising the scale of the project. So, are we just looking at the client just wants you to replace those boilers over there? I'm not interested in replacing anything else, just get the boilers replaced. Or are we looking at stripping the whole plant room out and starting again? So that's just categorising what we're actually looking at. But once we've done the risk assessment can help in actually narrowing down your boiler selection as well. So I think if you identify by doing a risk assessment that you've got, you have got access issues. So it could be that maybe, at the moment we've got 200-300 kilowatt boilers in there, but we're not actually going to be able to fit 200-300 kilowatt boilers into the plant rooms. We might need to actually look at maybe putting some smaller modules. So that can help on the risk assessment. But really, the following questions should be asked. Now we talk about access rooms to the plant room again. We mentioned that in the previous slide, and it's something that, again, this sort of a personal experience from my side. It's probably about 2 or 3 years ago now. I had a phone call from a contractor. He was on site with a boiler. It was another manufacturer's boiler. It wasn't one of ours. Had the boiler on site. They were literally trying to shoehorn this thing around the corridor. They couldn't fit the thing in. And he said to me, I'm really in a bit of a state here. He said, have you got anything that maybe we can unassemble, or something that's a bit smaller, or whatever, that we might be able to get off of you, and we could get it into the plant room. Luckily, we had something that we could unassemble. So after a bit of to and froing, he ended up sending the boiler that had actually been specified, sending that back, and then putting our boiler in because we could unassemble it. We could get it in quite easily. After the event, probably 2 or 3 weeks later, I saw this guy and I said to him, we talked about that project, and I said to him, didn't anyone actually pick up on that when they came to do a survey? And he said, well, he said, people come down here, they'd look around, and we just assumed, I suppose assumed is probably the worst thing you can do, but they just assumed that had been covered, but obviously it hadn't. So It sounds obvious, but it can get overlooked. Will the fittings of plant room, again, that kind of goes hand in hand with what we've just been talking about. I mean, what type of controls are required? If you think of older systems, controls, pretty antiquated. I mean, who knows? You might find it's got a lovely brand spanking new BMS system in there. But what type of controls do they want, and what type of controls are there? Two next points are the existing boilers running and pumps running. Two things I think on here is quite often if you go walking into a plant room and they've got 4 boilers sitting there, 400 kilowatt boilers for example, and 2 of the boilers on the end, they've got the casings falling off, the burners are hanging off the front, they've been isolated, and they've been isolated for, who knows, 2 years, 3 years or whatever. But that building is working quite happily just with those other 2 400 kilowatt boilers. You think to yourself, do we actually need to put 1600 kilowatts back in? Could we not get away with putting 800 kilowatts in? Because if you think, buildings change, the way they operate change, the windows change, things change in buildings, which actually can reduce down the heating requirements in that building. So, if they have got a couple of boilers that haven't been working for a period of time, then we actually need to put the same amount back in. But also, changing the boilers whilst you've got to try and keep heat on as well, because more often than not, the building occupiers, the building owners, they want their boilers replaced. They want brand spanking new boilers in there, but they want to keep, they don't want to compromise any heating or hot water whilst they're doing so. And that can throw up all sorts of challenges. And it happens often where it's like, well, we've got to replace those boilers, but we've got to keep heating on. So it's just how the process of going through that replacement. And finally, clearances. I suppose boilers, any bit of plant, every manufacturer would specify clearances around that bit of plant. So boilers are no different. And we specify those. The main reason we specify those clearances are so we can service the boilers, so we can replace components. Chances are the boilers, if you butted them up right up against each other, they'd probably work fine, but we wouldn't be able to service them. So if we can't service them, we can't replace any components, then the longevity of the boilers is going to fall through the roof. So I'd always say just be aware of what the clearances are and can they be achieved. And then moving on from that, another big thing really is legislation. And the thing with legislation, we could do a whole CPD on legislation, and that's on the cards. So I won't go into a great deal of depth on legislation, but the one I will go into a bit of depth is the first one about ERP. Are you all familiar with ERP? Have you heard of ERP? If you don't know what ERP is, it stands for Energy Related Products. And it was introduced, it was introduced really to the commercial market in September 2015. And what it was basically saying that any boiler under 400 kilowatts had to meet a certain efficiency. The efficiency, I can't remember exactly what it is, it's about 92.5% efficient, something like those things. And that's basically September 2015, that came in, so anything that didn't meet that efficiency, us as a boiler manufacturer, we couldn't manufacture it anymore. So, we had a lot of warning on this. I mean, the whole industry had a lot of warning. So we knew it was coming, and we obviously made lots of people, everyone aware of it as much as we could. But what we still come up against, and I come up against this on a virtually daily basis, is that you'll get maybe a building owner will say, well, okay, I've got 2 300 kilowatt boilers in my building, and that 400 kilowatts is is the actual boiler, not the whole installation. It's the boiler itself. So what he'll have is, so he'll phone me up and say, well, I've got 2 300 kilowatt boilers here. I just want to replace those boilers. Well, if they're just old atmospheric boilers, they're not ERP compliant. So he's then got to go down the route of putting in condensing boilers. So, and that throws up all sorts of challenges, as you can imagine. And it throws up all sorts of arguments as well, because then this happened to me last year, where it was actually a consultant engineer phoned me and said, I've got this project, we're replacing 2 150 kilowatt floor standing boilers. He said, I've already decided what I'm going to put in. He said, I've done my drawings, can you come and see me just to do a sanity check, just to make sure I've done everything right? I went in to see him. He probably picked off out of his library an ideal commercial brochure, probably dates back to the early 90s, and picked out an old atmospheric boiler that we don't even manufacture anymore, and decided he was going to put that into his project. So as soon as I sat down, I looked and said, well, you can't use those boilers, they're not ERP compliant. And he didn't know what ERP was, and I had to explain to him what it was, and he was almost arguing with me. No, he said, we can put these in. Anyway, after a bit of toing and froing and whatever, he kind of, he got the message, and we got around it. We could put some nice floor standing condensing boilers in. But for me, that just kind of made me think, well, us as a boiler manufacturer, we're talking about boilers day in, day out. And we know a lot about sort of legislation and those kind of things that are involved with when you are replacing a boiler. But someone actually used an analogy the other week, and they said, well, actually, you guys as mechanical engineers, you're spread thin across a lot of disciplines. And so he said, in a sense, you're like a GP, and we're like a specialist. So it's like you go to your GP and say, well, I've got a problem with my elbow. Your GP will look at it and say, yeah, I'm not happy with that. You have got a problem with your elbow. I'll refer you to an orthopaedic specialist. So, you're the GP, we're the orthopaedic specialists. So it's kind of, and that's where we can help you guys. Where if you have got a project, you can just give us a shout, and then we can go through those kind of things. So, but say there's other points of legislation as well. But you can go into so much detail with legislation, and it's something that. What I would say to you is, if you do have any issues or any queries, not just with legislation, could be anything. Just give us a shout, because we're a hub of information, so we're here to help you guys. So, but anyway, moving on from there, an example schematic, and really what we're trying to say with this slide is that, as you know, walking into a plant room, an old plant room, you'll have pipe work going out of that wall, you'll have pipe work going out of that wall, and you've got no idea where anything's going. And it can be a real problem to try and map out where everything's going. What we're trying to say here is, if you can find a schematic, that will really help you. It goes without saying, it's obvious, I suppose. But if you can find that, then that will really help you. Now, moving on from there, going on to ventilation. Ventilation, as you know, really, really important. Anything that burns anything needs oxygen to do so. Obviously, boilers, we're burning gas, so we need adequate ventilation to do so. Two pieces of guidance and legislation that we would always guide you to were for BS 644 and IGM UP10. They're really your go-to guides for ventilation and fluid. What we need to identify, we're in our existing plant room, we need to see, well, what is our setup at the moment? What have we got? What is our ventilation? So, one thing I would mention is that if you go into a plant room and it's maybe, it's not a very warm day outside, it's in the winter, and you walk into that plant room, the boilers are firing, but that plant room's really hot, you walk in and think, it's good. It's a bit warm in here. Straight away, that's a key indicator that ventilation isn't up to scratch in that plant. And something happened to me. It was a couple of years ago now. I had to go down to it was in London, the City of London Magistrates Court. They were looking at replacing their boilers. We went down into the plant room. The plant room was right in the basement. Went walking in, and straight away I walked in, and it was warm. And we looked at the ventilation, and the ventilation was nothing. And these boilers they had in there at the moment, they seem to be working okay. But I said to them, I think we need to look at ventilation. They wanted to do that replacement really quickly. Now, because they had problems with the ventilation, it put the project back a year because they had to sort out the ventilation. So again, it's a big thing we need to be looking at. What we need to identify is the current ventilation that we've got in this plant room at the moment. So we're looking at mechanically or naturally ventilated. Obviously, mechanically ventilated, we are drawing the fresh air in via a fan. Obviously, naturally ventilated. We've got a nice airy plant room, nice louvers on the walls or the doors or whatever. We're just drawing it in naturally. Is the ventilation adequate for the proposed plant? As I said earlier, is it adequate for the plant you've got there at the moment? So we just need to be aware of what that ventilation is and what we're looking at putting in, and is it going to be adequate? Obviously, it's mechanically ventilated, it needs to be interlocked. So obviously interlocked with the boilers. So if that mechanical ventilation fails, the boilers won't be able to fire. And the air source must be direct to outside. That's something that, surprisingly, I do get asked a fair bit, where we're looking at a plant room, and maybe you're thinking, well, actually, I can't get the ventilation direct to outside, but we've got a corridor out there, that corridor, we've got adequate ventilation there, that should be okay. You can still shut off that corridor. They can still, even if there's no doors there at the moment, they can still put doors in there. So what I say is always go direct to outside, because you can always, unless someone actually physically goes out and boards up a louver, you're not going to lose that ventilation. And then on the right hand side, that's from 6644, and that's just some simple guidance on high and low ventilation in the plant room. Per kilowatt, or centimetres squared per kilowatt. So that's an easy kind of go-to guide. I can email this whole presentation to anyone who needs it. So there's a few little snippets in there which can be quite useful. And then moving on from there, we need to look at the flues. Again, IGN, UP10 and BS6644 are the sort of go-to guides. So if we want to look at, we want to possibly use the existing flue system that we've got in that plant room. First of all, we need to identify, are we looking at an open flue system or a room seal flue system? So when we're talking about open flue system, we're drawing a combustion air just from the plant. So room seal, we're actually ducting it into the boiler itself. It's almost like a snorkel. We'll put there about considering existing dilution system may be used. Again, the question does get raised a lot about can you put condensing boilers on flue dilution systems? And the reason the question gets asked is because, as we know, the way that the flue dilution system works is obviously it's diluting the flue gases, so you can terminate them at low level. But also what it will do is by doing that, it cools the flue gases. And when you cool flue gases, you create pluming. And the way that a condensing boiler works is because it's taking the latent heat of the flue gases, it's cooling the flue gases, and it's naturally creating more pluming. So if you're taking off some old atmospheric boilers that maybe had flue gas temperatures of over 100 degrees, that flue dilution system will cool it down, and you'll get a fair amount of pluming at the exhaust lever. But because your condensing boiler has already cooled it down, and then it goes into the flue dilution system, that cools it down even more. You create even more pluming. And I've spoken to people about this before, and there's been horror stories of people thinking that a building's on fire because there's so much pluming coming out of this exhaust lever. It's not dangerous, it's perfectly harmless. But what it can do is it can create a nuisance. So what I would say is that put the boilers on the flue dilution system, but just be aware of what's around the building, because you don't want to start annoying the neighbours, or you start complaining on it. This time last week, we didn't have this amount of pluming, and now we've got all this pluming coming out. Suitable terminal location. Again, if we're looking at using an existing flue system, you're going to have a flue terminal somewhere. Obviously, be aware where that is, because it could be that maybe that flue's been installed for maybe 10 years, and other buildings have gone up around that flue, or other structures have gone up around that flue, and now it wouldn't meet current legislation. So just be aware of where it is, and does it still meet current legislation. The material of the flue should be stainless steel. Obviously the sizing of it as well. So if we are looking at using that existing flue, be aware of the sizes, just so we know it's going to be okay to use on our replacement boilers. I'll probably say chances are, if you're taking out atmospheric boilers and putting condenser boilers in, that flue's probably going to be too big. Because atmospheric boilers relied on larger flue diameters, whereas condensing boilers now, because of the nature they work with premix burners, they've got positive pressure at the flue spigot, so we can, as a bonus for that, we can start reducing flue sizes down. Chances are it may actually be too big, so you might actually have to line the existing flue system. So the condition of the flue goes without saying, if it looks a bit corroded or whatever, change it. The root of the system as well. You've got to know where the root is to be able to calculate whether it's going to be suited to your replacement boilers. And I had a project earlier this year where I had to go to a hotel, and they were looking at replacing 3 wall-hung boilers, and they wanted to use the existing flue. So I went there and okay, let's have a look at it then. Boilers are on the wall, flues went out the wall, out the plant room, and we had no idea where those flues went. All the guy could tell me was, they would terminate 10 metres over there. But we didn't know how many twists and turns there were, whatever, it was So we couldn't really say for definite whether it was going to be okay. Chances are it would have been, because those boilers were, they were premix boilers anyway, so, and they were the same output, so chances are you wouldn't have had an issue, but you can't say that to a client, well, chances are your fluid will be okay, we'll wait and see once we've installed it. It's not how it works. So, so you just got to be aware of the route. Draft stabilisers and dampers. So a bit kind of old school, I suppose. Really, you don't tend not to see draft stabilisers now on modern flue systems. But it could be that you go into that plant and you think, well, actually, we've got draft stabilisers there. Do we need them or don't we need them? Chances are you probably won't need them because draft stabilisers were put in to stop, particularly for atmospheric boilers, to stop the flame being pulled off of the burner bars. Where now, well, the way that modern condensing boilers, premix boilers, the way they just work in a completely different manner. So it could be that we don't need those stabilisers or dampers, so we could have to take that out. And obviously condensate drains. So if we're looking at a flue system, putting condensing boilers on, we need to get rid of that condense somehow from within inside that flue. So we need to have adequate condensate drains within the flue system. And on the right-hand side, that diagram is from IGM UP10, and you can see it's a diagram of a building with various termination points on there for flues. Basically, you're looking at that. You read that in conjunction with the next one, and basically, dependent on where your flue terminal or your proposed flue terminal position will be, that will then tell you how far away you need to be from opposing structures, from adjacent flue systems, air grips, that kind of thing. So, and hopefully you all have access to IGM UP10. But like I say, if you haven't, I'll quite happily send this presentation over to you, so you've got that. And then moving on, so we've ascertained whether we've got a room seal or an open flue system. Now, but then to further complicate it, we then have to categorise it even further. So when we say open flue, we mean type B, room seal flue is type C. But then once we've ascertained, okay, we've got an open flue like we have here, we now need to subcategorise it. And that subcategorisation is based on really the boiler, it's how your boiler operates. So if you look at this works, get this to work. Type B11 there, that's your classic atmospheric boiler. You've got a draft diverter on the top there, obviously burner bars, and just drawing combustion air in the bottom. That's your classic old school atmospheric boiler. All the way through to type B23, which is here, which that I would probably say 95% of the boilers that we manufacture now are type B23, where obviously we're open flue, so we're drawing combustion air from within inside the plant room, but we have a fan, and that fan is upstream of the burner. And what that fan is, that's our premix fan. So what that fan is doing is that's drawing in our fresh air and our gas. It's mixing it to the optimum mixture, and then that goes into the burner and combusts. So, and because we've got that fan in there, that fan is actually pushing through or creating a positive draft inside the boiler. So we get a positive draft at the flue sweeper there. So that's probably 95% of the boilers that we would manufacture. Probably a large proportion of boilers out there on the marketplace now would be type B23. So it's just really dependent on really how the burner and the boiler's operating is dependent on what your subcategory is. So, and then this isn't working. We do exactly the same with room seal. So we're now type C, and again, it's just dependent on how the boiler's operating. But really that's your classic wall-hung condenser boiler. So probably similar to exactly what you've got at home, I suppose. But yeah, it's just got those subcategories based on how that boiler operates. But other points we're making on this slide is things like the boilers must be in the same room. If they're going to go on the same flue system, for example, they've got to be in the same room. Other things, you can't mix and match different burner types on the same flue system. So you couldn't put, for example, an atmospheric boiler and a condensing premix boiler on the same flue, because an atmospheric boiler is relying on almost suction as such, where a premix boiler is relying, it's got that positive pressure straight away. You've probably got 200 pascals of flue speaker. which is pushing away. And if you put those two different burner types in the same flue, you just get an imbalance in the flue system, and it just won't work.